Hi, so today we'll be talking about trig equations. So a basic trig equation is a cosine or sine or tangent, whichever, omega x plus chi plus b, where your a is your amplitude, which will always be a positive number, which is why we have the absolute value symbols next to it. Omega changes the period, and chi represents the phase shift. So this is going to be our example. 2 cosine parentheses 1/2 x plus pi over 2 and parentheses minus 1. So the first thing that we're going to do is find the period. So since we know it's a cosine, we know the period is going to be 2 pi. So the period for a cosine and sine is 2 pi, always. And tangent is pi. So to figure out how our period has changed due to this equation, we're going to use period is equal to 2 pi, this cosine, over omega, which is right here, and for this, it's 1/2, so 2 pi over 1/2, which you can cancel your 2's, and you're left with pi, is your new period. Okay, for the phase shift, it's equal to chi over omega, which for this function, our chi is pi over 2, and omega is 1/2, and again, our 2's will cancel, and we're left with pi. But you have to be careful because in our equation, it's adding pi over 2. Now, remember when we did regular transformations? Something with a negative sign would shift it to the right, and something with a positive sign would shift to the left. The same thing is happening here in trig. So, because there's a positive pi over 2, it's actually going to be shifting left pi over 2. So, over here you have to put a negative. So it's basically saying you're using pi units left. Okay. And finally, for our reflections, if the negative sign is in front of the A for amplitude, it's going to be a vertical reflection, and if it's in front of the X, it's going to be horizontal reflection. So, for this scenario, our negative is in front of the A, so we're going to have a vertical reflection. So, to go over it again, we have a period of pi, a phase shift of negative pi, and a reflection vertically. So now that we've done our calculations and figured out our phase shift and our period, it's time to graph it. So to go over what we already calculated real quick, we have our period as pi, our phase shift is negative pi, or pi units to the left, vertical reflection over the x-axis, and the amplitude is 2, and due to the negative 1 on the end of the equation, we're moving the whole thing 1 unit down. Okay, so to find out our points, so our first point of 5 is going to be where you have x is equal to 0 at a normal cosine graph will start on 0 if you're looking at just the plain old period. So you're going to take that 0, and because of our negative pi phase shift, we're going to subtract pi from 0, which will leave us negative pi. Our second point, we're going to take pi, which is our new period, times 1/4, and then subtract pi for our phase shift, which will leave us pi over 4 minus pi, which is equivalent to negative 3 pi over 4. The third point will be pi times 2 over 4, or 1/2, and then subtract pi for your phase shift, and you will end up with negative pi over 2. Our fourth point, same thing, pi times, this time 3 over 4, minus pi, which will be equal to negative pi over 4 when reduced. Now our fifth and final point, you have to remember here is that usually a cosine graph goes from 0 to 2 pi, but in this case it's only going from 0 to pi. So our typical endpoint for a graph like this would be pi. So that's what you're going to use for your initial value. So you're going to have pi minus pi because of our phase shift, which will leave us with 0. So now we have our x values. So to graph, we're going to start here. So if this is negative pi, so that's going to be our first point. And we know a normal cosine graph would start at the top and then swoop down to the middle and back up. But since it's a negative, we're going to start at the bottom, which is going to be negative 2 due to the amplitude. So first point is negative pi, negative 2. And then we're going to move to our next x, which is negative 3 pi over 4, and we have negative pi 2, negative pi over 4, and then 0. So our next cosine point will happen at the negative 3 pi over 4. This time it'll be right on the x-axis, and that doesn't change because our reflection won't change that. And then our middle point will be negative pi over 2. And again, usually on a cosine graph, this would be at the very bottom, but because it's reflected, it's going to be at the very top at positive 2. And then we go back down at the negative pi over 4, and we finish up at 0, negative 2. So that represents one period of the example.